All right, here we go on the plate boundaries and volcano notes. So this part kind of should sound familiar, hopefully, but make more sense. Convergent plate boundaries, and the picture here, we've got a mountain. You can see the layers where this used to be flat, but as it gets crushed together, you have a mountain piling up higher and higher and higher. This is a convergent plate boundary. This is where plates are coming together, obviously. And so what you get a lot of time are mountains. When two continental plates come together, you get mountains. And it's a constructive process. So it's constructing new features, constructing new mass on the surface of the Earth. And mountains are basically the folding and wrinkling of the rocks of a plate. Okay. So that's the first part of convergent plate boundaries we're going to cover. So then, to add to this, we have this thing called subduction. You know, if something's getting pushed down into the Earth, subduction is happening. Well, I came up with a nice picture for you. Subduction is dense ocean plates pushing under less dense continental plates. And so here we have an ocean plate on this side. Here we have a continental plate on this side. Now, as a drawing, I gave you part of the drawing, but here's our ocean plate. The ocean plate's moving in this direction. As it pushes in, something's got to give. Now, the ocean plate is more dense, and it starts pushing under. The continental plate is less dense, and it's going to rise to the top. It's going to be on the top of the Earth. Well, as this ocean plate gets subducted underneath, what ends up happening is some water, some dead stuff in the rocks winds up getting pushed down with it. And that stuff can't stay deep down in the Earth because it boils, in water's case, that turns into a gas. And other material like algae, other stuff, burns up and turns into carbon dioxide gas. And this gas can't stay inside of the Earth. Well, what happens is that those things build up pressure, and those power volcanoes and volcanic eruptions up on the surface near subduction zones. So this is all an introduction going to the next part, which we'll get to in a moment. And I'll note that this is a destructive process down here. This is destroying the plate as it goes back into the Earth and melts. So what we have then, here's a map of most of the volcanoes on the Earth. If you take a look, this is the Pacific Ocean. The Pacific Ocean seems to be surrounded, by volcanoes. And if we mapped earthquakes, most earthquakes also happen in the exact same spots here. And we call this the Ring of Fire. Okay? So the Ring of Fire is caused by the Pacific plate being subducted under the continents as the Atlantic expands. So over here is the Atlantic Ocean. As that Atlantic gets bigger, the Earth is a sphere. So if you make one part of that sphere bigger, a different part's got to get smaller. So in other words, the Atlantic Ocean is pushing this plate over here. The plates are going in this direction here. Okay, the Atlantic is getting larger. It's also pushing these plates this way. And what ends up happening is that this Pacific plate is getting pushed under from both sides. And as it gets pushed under, that subduction powers all of these volcanoes that we see. So to finish the notes off, this causes most earthquakes and volcanoes to surround the Pacific Ocean. That's the Ring of Fire right here. It's being subducted because it's getting smaller. As the Atlantic on this side pushes bigger, this one has to get smaller. If you have a question about how this works, please ask me in class. Now, to finish the notes up on the second page, we have divergent plate boundaries. It should be review again, but to have that review, we have plates being pulled apart by these two arrows right here. This is a continental plate that's starting to get pulled apart. Okay? As a continent pulls apart, normal faults, that's what you're seeing right here, that's what you're seeing down here, begin making what's called a rift valley. Okay. If you're interested in rift valleys or want to learn more, look up the Great Rift Valley in Africa, where this is happening right now. There are people who live here, and their groundwater is being basically boiled off as their groundwater is exposed to all this heat, and they have steam coming out of the ground, and they live right in here. Anyway, eventually, it pulls so far apart, and the land drops so low that it's underwater, and eventually a mid-ocean ridge forms. So that's what we have now. This is the Atlantic Ocean, basically, and it's been doing this for a very long time. The ocean crust is pushing outward, continental crust, and this is more along what we have in the Atlantic. So to look at the Atlantic, it's similar to the Ring of Fire in that, take a look at these earthquakes and volcanoes that we have along the ridge. So the result of that spreading is the center of the Atlantic has a line of volcanoes and earthquakes. You'll notice over here, this is Hawaii and Haiti and Virgin Islands. There's a lot of subduction happening there, so there's a lot of volcanoes and earthquakes over there. And then there's other random areas here in Iceland. There's a lot of volcanoes as well as this gets pulled apart. So you should understand that the mid-ocean ridge and the Ring of Fire are similar in that they, the plates are either coming apart at those points or going together at those points, and that concentrates all the earthquakes and volcanoes near those areas. Now there's one final area that doesn't fit into either of these that we've talked about. Now here Hawaii is on a map, pretty dull, but if you change it from map to satellite, this is just Google Maps, by the way, you can see on the ocean floor there's a lot more going on. And so here's where the active volcanoes are on the main island here. So this island is getting taller and bigger actively every year. There's volcanic eruptions that make this island bigger and everything else. If we look, there are older volcanoes here. There's even older volcanoes that aren't erupting anymore here, and so on. Older yet, older yet, older yet, all of that thing. Okay. So what it looks like is that the volcanoes are moving this direction. They were here, now they're here, now they're here. Okay, now they're here. Actually, today they're here. Tomorrow they might be here. And so what people thought for a long time was, oh, well, the volcano has some sort of hot spot on the plate here that is moving this way. Well, I should mention this is one solid plate here. There's no subduction, there's nothing really going on anywhere near it in terms of plate tectonics. What there seems to be is a hot spot underneath this plate pushing magma up through the plate and causing this to happen. People used to think that hot spot was moving, like I was saying, but what it seems like is that if you put your finger, let's say the volcano is here. Put your finger right here on the screen, or imagine the spot on the screen. What seems to be happening is that the hot spot stays here. So keep your finger here. But over time, the plate has moved like this. And the hot spot stayed in the same area. Now the hot spot is still here, but this is where the plate is, so this is where the volcano is happening. In the future, it's likely volcanoes, this is thousands or millions of years in the future, volcanoes will be erupting out here, just because of the way the plate is moving. Okay. If you take a look up and zoom out, you can see that this has been happening for a long time. That this plate has been moving across this hot spot. I don't know if these are connected or not, or if I'm just seeing things, but it certainly looks like this is all a part of the same system. The same thing happening. So if we go back to the notes, at the bottom of the page we have hot spots. Okay. Now take a look at the pictures. it seems like we're in the middle of the Atlantic plate. There's this mantle plume, this hot spot that's pushing up into Hawaii. It used to be there, but the plate seems to be moving away from where the hot spot is. Here's old volcanoes, here's old magma chambers that powered these old volcanoes, but now it's here. As this plate continues drifting this way, the next one will be here as here shifts over here. Anyway, so a hot spot is, here's where in the notes, Hawaii is the center of the Pacific plate. A hot spot from a mantle causes volcanoes there to continuously build the island. So you should know that hotspots can happen on the surface of the Earth too. This is a different reason for volcanoes to happen, and it's not due to subduction or plate separating. It's due to these mantle plumes, these really hot spots on the mantle. That's the end of the notes for lesson 1. Please let me know if you have any questions.